Hi, my name is Luke Webster, and the title of my research presentation is called A Simple Equation to Estimate Urinary Flow Rate Using Urine Creatinine. As we all know, being able to accurately chart total daily urine production is important in both the inpatient and outpatient settings. Daily urine production is frequently used to monitor diuresis, calculate protein excretion, as well as to calculate hormone concentrations. This is frequently difficult as patients can discard their urine or intake and output can be inaccurately charted. We therefore created a novel equation and hypothesized that this equation, which was formed via the creatinine clearance and Cockcroft-Gault equations, could be used to predict urine flow via minimally invasive means. To test our equation, we looked at patients in both the ASK and the combined clinical trials that had submitted a 24-hour urine collection as part of inclusion. We then used a previously derived equation that was derived by Ix et al. Back in 2011 that looked at estimated and measured creatinine excretion rates. If those samples that were provided by patients as part of inclusion in the clinical trials were discordant by greater than 20%, they were discarded. The way we derived our equation is as follows. We started with the creatinine clearance equation in A and the Cockcroft-Gault equation in B. We then set those equations equal to each other because both were solving for creatinine clearance. If you simplify, you're able to ultimately wind up with urine flow, EV, in milliliters per hour, which can be derived by age, weight, gender, as well as urine creatinine concentration. Our final equation, equation E, has a post hoc modification factor that I will discuss later. Table 1 shows the baseline characteristics of our population in both the ASK and combined clinical trial participants. This is stratified by urine flow rates. ASK is on the left and combined is on the right. As you can see, ASK has a larger population than the combined clinical trial. Another major difference is that all kidney disease in ASK was due to hypertension, whereas chronic kidney disease in combined was due to a myriad of different conditions. In ASK, we had 570 patients that met our inclusion criteria out of 1,090. We then plotted our measured and estimated urine flow rate, which showed we had a high strength of correlation. Bland-Altman analysis of our data showed that we had a systemically lower flow rate of 9.5 milliliters per hour, which accounted for a negative bias. Accuracy of this equation showed that 36% of our estimates fell within 10% of measured. Given this negative bias, we added a post hoc modification factor to D, creating equation E. As expected, this led to an improvement in accuracy. We then tested both equation D and E in combined. Out of 205 individuals, 123 met our inclusion criteria. Again, estimated and measured urine flow rates were highly correlated with each other. Using equation D, the Bland-Altman analysis showed that we had a negative bias of 14.8 milliliters per hour, actually worse than our initial study in ASK. Accuracy was worse as well, with 20% falling within 10% of predicted. However, when we used equation E, the bias improved to 5.3 milliliters per hour, and accuracy improved as well, with now 43% falling within 10% of measured, and 93% falling within 30% of measured. When looking at this on a graphical scale, you can see ASK on the left and combined on the right. Figure A and C show our correlation between estimated flow rate in milliliters per hour and measured flow rate in milliliters per hour. Equation B shows our Bland-Altman analysis of equation D in the ASK population, and this plots mean of estimated and measured flow rate versus estimated minus measured flow rate on the y-axis. The dotted lines on both equation figure B and D are our 95% confidence intervals, and the black line represent our systemic bias of the sample. Here in figure B, the systemic bias is 9.5, and here in figure D, which shows equation E in the combined clinical trial, has our negative bias of 5.3. So in conclusion, we were able to create a novel equation using the Cockcroft-Gault and the creatinine clearance equations. And we were able to test this equation to estimate urine flow in patients with chronic kidney disease. In ASK, our equation underestimated urine flow rate by 9.5 milliliters per hour. This led us to create a equation E with a post hoc modification, which showed improved bias and accuracy in combined. So overall, we are excited about our success with this equation and hope that it can be used to critically evaluate 24-hour urine specimens in both the inpatient and outpatient settings. I would like to thank my research team for all of their help with this project, as well as my mentor, Dr. Ix. Thank you.